Hi everyone, let's do a little bit more practice on graphing translated parent functions. I did introduce it to you in the previous lesson, but I'd like to go into more depth. So let's just first start with the parent function of being quadratic, and hopefully you remember that this is y equals x squared. And so that would be something like if we plugged in -1, I guess, actually let's start with -2. -2, -1, 0, 1, 2. Plugging that in, I get -2 squared is equal to 4. -1 squared, which is -1 times -1, is equal to 1. 0 squared is equal to 0. 1 squared is equal to 1. And 2 squared is equal to 4. All right, so I'm going to just go ahead and graph that. This is my parent function. I'm going to just highlight it in red because, actually no, I'll highlight this whole thing in red just to indicate that this is my parent function, meaning original function, kind of the standard one. So this is going to be -2, 4, and then I have the reflection of that. Then I've got -1, 1. I've got 0, 0, 1, 1. Yeah, I think I've got them all. So I'm just going to go ahead, I'm going to graph that. And I know this is a little strange, but I'm going to go ahead and make these points bigger because we are going to have to do something with these points. All right. So now I want to talk about translating this. Translating means moving left or right, up or down, or maybe a combination of both. So let's go ahead and let's change our colors here. And if you do have a different color, that'd be great on your graph as well, or else actually it does get kind of confusing if you use the same color. So what I'm going to do is I'm going to give you something that looks like this. We'll call this example 1. And we'll have y equals parentheses x minus 2 squared plus 3. The first thing we do is identify what the transformation is. And so here, I know it's inside the parentheses, so I know that's a left or right. And I also know that it's the opposite of what I think it is. So in this case, you think it's left because it's negative, but actually it's the opposite. It's going to be a right 2. Now on the outside, meaning not in parentheses or not in a grouping symbol, it's exactly what you think it is, and it's an up/down. In this case, it's going to be an up because it's a plus. So this is going to be up 3. Now what I do next is basically take my red parent function and I'm going to move every point right 2 and then up 3. So for example, I'm going to take this point, I'm going to take it right 2 and then up 3. 1, 2, 3. And that's where I put my point, right there. Okay, same thing with these other points. I'm going to go right 2, up 3, put a point. All right, I'm going to do the rest. There we go. And so it's really nice that you're kind of able to check your answer. It should not look stretched or anything like that. It should look like the exact same function or the exact same shape, but it's just going to be translated. It's going to be moved left, right, up, or down. All right, so my final answer is going to be that in green. Technically, if I asked you to graph this thing in green, you should erase the red. But as long as you maybe make it clear on your paper that this is the function x minus 2 squared plus 3, and that the other one is just the parent function of y equals x squared, then I'll be happy. All right, next slide. Let's go ahead and let's graph our absolute value of x function. That's absolute value. As a reminder, that's the function y equals absolute value of x. So if I go -2, -1, 0, 1, 2, remember absolute value is the distance away from 0. So all you have to do is make the negatives positive. And then everything else just stays exactly the same. So graphing that just looks like a line with a slope of 1, just like that. And then over here, same thing, but a slope of -1 because you're going down. Let's just go ahead and let's pick a few points. We'll maybe pick this one, and we'll pick the 2, and that one right there. All right, let's go ahead and let's deal now with example 2. So we'll go example 2. What if I asked you to graph y equals the absolute value of x plus 3 minus 4? So same thing as the last problem, we have to identify what it's saying. Inside the grouping symbols, it's the left/right and the opposite of what we think. So this would be a left 3. Now here, it's on the outside, it's not in the grouping symbol, so it's an up/down, and in this case, it's going to be a down. It's exactly what we think it should be. So this would be a down 4. All right, now I'm going to take each of these red points and I'm going to move them left 3, down 4. So this one right here, I'm going to move it left 3 and down 4. And here it goes right there. Same thing with this one, I'm going to go left 3 and down 4. Same thing with this one, I'm going to go left 3 and down 4. Okay, now this one would be left 3. Now it's super tempting to just say, oh, I got the pattern, but I can't tell you how many times a student has accidentally just guessed where the function goes after drawing a few points and then gotten it wrong. So I know it takes an extra few seconds, but I highly recommend making sure you do enough points. And then once you've done quite a few points, you can see the shape. But don't do it too early. Students oftentimes get that wrong. All right, so again, if you want to erase the red one, you can, or you could just point to this one, say y equals absolute value x plus 3 minus 4, and then you could point, if you want, to your parent function, say this is y equals absolute value of x. All right, ladies and gentlemen, we have one more problem, and that's the square root. Now, I like to think of the square root function as kind of looking like a seagull. And we remember that y equals square root of x looks like that. Its general shape is like that, like a kind of half a seagull, right? If you think about a seagull, it looks like that, but we're really just choosing half of it. All right, so square root of x, this is a little bit more tricky in terms of choosing our values, but I'm going to use 0, 1, 4, and 9. Because the square root of 0 is equal to 0. Square root of 1 equals 1. Square root of 4 is 2. Square root of 9 is 3. If you're not sure why, it's because 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. 0 times 0 is 0. So I'm just going to have a 0, 1, 2, and a 3. All right, graphing those points, I have the point, let me go to red, just keep it consistent here. Okay, so I'm going to have my parent function in red again, so I'm going to have the point 0, 0, 1, 1, 4, 2, and 9, 3. There we go. There's my parent function, kind of like that seagull. All right, now let's go ahead and do example 3. I'm going to choose my green again because now we're really talking about translating. So my example 3, I would like to graph the following. Let's graph x plus 4, and then we'll go plus 5. Inside the grouping symbol is left/right. You're choosing between left and right. And here you're going to choose left because it's the opposite of what you think. And here you'll choose up 5. It's exactly what you think it will be. So I'm taking each of these points and I'm going left 4, up 5. Okay, I just translated this point right here. Now I'm going to do this one, left 4, up 5. Same thing with this point, left 4, up 5. And last one, left 4 up 5. Okay, when you're done with that, you're just going to draw your general shape, and it should look exactly like the other one, just moved left, right, up, or down, depending on the problem. I'm going to point to this one and say that this is the square root of x plus 4, and then plus 5. And then our red one is our parent function, meaning the original function, the basic function, y equals the square root of x. This one right here. That's it for now, folks. Thanks for watching.